Geometry 9.1 notes. All right, what I want you to do first is just practice your vocabulary. So go ahead and put a letter by every number over here. Okay, so for example, number 1 says congruent circles. So if we look at this, the choices A through J, which picture displays congruent circles? It's going to be this one right here, F, because those circles are exactly the same shape, same size, they have the same radius. So that one would be F. Okay, go ahead and do the rest of these. Pause the video. All right, go ahead and check how you did on the warm-up. So E should have been concentric circles. COE was the radius. A was a chord, DC. Number 5 diameter was DAB. Number 6, a tangent line was BTG. Number 7, central angle was angle PTR. Notice central angle does not have an arc on it. It's going to have an angle mark. Okay, minor arc, that's where you use the 2 letters, GRQ. Major arc was I, PQR, PQR. So go in the direction that it says. And then semicircle, HPRQ. PRQ just makes half of the circle. All right, let's take a look at some more vocabulary. So remember that an arc is an unbroken part of a circle. Types of arc, you could have a semicircle, major arc, minor arc. Central angle is an angle whose vertex is in the center of the circle and whose sides pass through the endpoints. So like in this case, our central angle would be angle RPS. So we could say the measure of angle RPS is 50 degrees. Also remember the central angle is equal to the measure of the arc. So we could say the measure of arc RS is 50 degrees. All right, think back to triangles. Remember the isosceles triangle conjecture says that if a triangle is isosceles, then its base angle, so if we know 2 sides are equal, then we know 2 angles are equal. So its base angles are congruent. All right, go ahead and flip to the next page, page 8. This one's just refreshing a little bit on the point of tangency. So if you think of like that beach ball kind of sitting on the ground there, right where it connects to that line is called the point of tangency. So if you have 2 lines that are tangent to a circle, but they meet out here at a point, they both have points of tangency. So B would be a point of tangency and C would be a point of tangency. All right, so again, tangent line in a plane intersects the circle exactly once. All right, tangent conjecture says a tangent to a circle is perpendicular to the radius at the point of tangency. Okay, so you have this tangent line. It is tangent to the circle, tangent to the radius, and it's going to make a right angle with the radius at that point of tangency. How's that going to help us? Well, now we're going to have some right triangles and be able to use the Pythagorean theorem to find some missing sides. All right, converse of the tangent conjecture just says if the given radius, a perpendicular line is constructed where the radius touches the circle, then the line is tangent to the circle. And finally, the tangent segments conjecture says tangent segments to a circle from a point outside the circle are congruent. So right here in this case, we would say AB is congruent to AC. That is congruent to that. Okay, as long as they meet up at that same exterior point. And these are both tangent to the circle. All right, two circles tangent to the same line at the same point are called tangent circles. They can be externally tangent circles or internally tangent circles. So there's the two scenarios where those could be. All right, now let's practice using some of these theorems. Let's go to page 9. All right, so you've got two tangents to the circle, TA and TG. If the major arc formed by the two tangents measures 220, find the measure of angle T. Okay, so remember when you have a tangent connecting with a radius, which that's what AN and NG are going to be, it's going to make a right angle. So that's going to be 90, that's going to be 90. Now, we got to use some of our ideas of the arcs. So it's saying this arc over here is 120. Well, we can find the leftover on the circle. It's just going to be on this side of it. So what is that leftover? So what we can do is take 360 for a whole circle minus that blue one, 220, and see that we would be left for the red one to be 140. So that red arc there is 140 degrees. Well, if I know the arc, now I know the central angle, 140 degrees. So now, can you guys see the kite? So we have a shape. It's a quadrilateral four-sided figure where we knew these side angles were 90. We have that top angle or the right angle to be 140. Well, now I can find this leftover angle T, which is my goal. So do you remember in a quadrilateral, there's 360 degrees. So I can add 90 plus 90 plus 140. So we've used 180 plus 140. Which would be 320. And then subtract that from 360 to find what angle T would be. Okay, so if you wanted an equation, you could say, okay, we've used 90 and 140. What is that last angle to add up to be 360? So again, that will get you the same outcome. 320 plus x equals 360. So then x is going to equal 40 degrees. Okay? All right, example 2 says, given the measure of angle ADB is 40 degrees, find the measure of angle DAB. ADB, this one's 40. Find the measure of angle DAB. All right, so what's happening here, it's kind of hard to see this as a dotted line, but remember, since these are tangent segments, tangent lines here, they are equal. So now it's just going to make an isosceles triangle where the vertex angle there is 40 degrees. You've got your congruent sides. So now we can figure out what DAB is. If we go from D to A to B, it actually wants to know what angle A is. So there would be your A, DAB. All right, so again, degree in a triangle, we could think of these as the same thing. So if we used x plus x, because it's isosceles, those base angles have to be equal, x plus 40. Or you could just take away the 40 to get 140 and then divide by 2. So either way, the measure of angle DAB should be 70 degrees. All right, let's try another one here. Given AC is 6, always helpful to mark your diagram as you get started here. CD is 10, and then BD is 2x plus 1. Find x. So what we can do, I'm going to kind of use this the top triangle here. You can see this is going to make a right triangle because remember at the point of tangency, that made a 90-degree angle. So I'm going to call this for a minute y. So we're going to go Pythagorean theorem, a squared plus b squared equals c squared. So we have 36 plus y squared equals 100. So go ahead and see if you can finish that problem up to tell me what this side is. Once we know what that side is, what we can do is just set that number equal to this other side, 2x plus 1. So see if you can finish that up and find what x is. All right, so from there we can subtract that 36 to get 64. So we say y is 8. So this whole side is 8. That means this whole side is 8 because they are both tangent segments or tangent to the circle. So we're going to let 8 equals 2x plus 1. So subtract our 1, divide by 2, x equals 3.5 or 3.5. All right. Next, what type of quadrilateral is ABCD? We kind of talked about that a little bit ago, but since these are both 90 and these are radiuses, these are equal, then it's got to be a kite. Okay, because it has two pairs of consecutive sides congruent. All right, this one we've got again a 90-degree angle. Remember, every time that radius meets up with a tangent line, it makes a 90-degree angle. BFC is 50 degrees. FBC is our goal to figure it out what it is. So why don't you see if you can do example 3, A and B. Go ahead and pause the video. For B, I think we're going to have to use that Pythagorean theorem. All right, for example A, you end up having the angles in a triangle. So we just need to subtract from 180. We've used 50 and 90. That means there's 40 degrees left for that angle FBC. For part B, we need to use the Pythagorean theorem. Now, it did give us that this side was 5 right there, but I would actually use that to figure out this side, since they're radius to the same circle, they're both going to be 5, and then almost like ignore this because it's going to be harder to call this x plus 5. If we just call that third side x, that's going to be easier to solve. So if we do that Pythagorean theorem, a squared plus b squared equals c squared, then we get 89 equals x squared. Take the square root of both sides. X equals the square root of 89. I don't think there's any perfect squares that go into 89, so we can just leave it like that. If you did calculate the decimal of it, you could just go ahead and round to the nearest hundredth to get 9.43. All right, so your assignment is the 9.1 worksheet. It's on page 11 and 12. So try to get that done for tomorrow. All right, let me know if you have any questions. Have a great day.